All right, so we've got kind of a lot to talk about in this video. Good thing our last one was so short. We're going to work on understanding domain and range. So our question is, what are the domain and range of the function defined by y equals x squared minus 3? Here's a graph of what that looks like. So for domain, let's go ahead and get a definition in there. So you guys will see definitions pop up sometimes. If it helps to pause it, because I'm just going to jump right in and talk about it. The domain is the set of all possible inputs for a relation. Keyword here is inputs. So what we're talking about is if you look at our function over here, the inputs are the x values. So what can you input into this equation? Positive numbers, negative numbers, what numbers are you allowed to square because it is an x squared. So that's our domain. All right, moving on to range. Range is the set of all possible outputs for a relation. So range is your outputs. So you're going to put numbers in for your inputs. What kind of numbers do you get back out? We're talking the y values for a relation. So we have a couple types of notation that we're going to use when we are defining our domain and range. The first one is called set builder notation. So I'll write that out with you guys. Set builder notation. All right, so what that's going to look like for our domain, I'm just going to use a domain. So it starts with a bracket, and domain is going to be your x values. So x, and then it gets a bar like that. So what this means is the set of all x values such that, and then what are we going to say about the x's? So in this case, what is our domain? What kind of numbers can you square? What would our inputs be? Can you square positive numbers? Yep. Can you square 0? You can. Can you square negative numbers? You can. So basically our domain is going to be all of the real numbers. So we're just going to say the domain is the set of all x such that x is a real number. That should say real, and I'm going to just abbreviate number. Okay, so your range, let's put range in set builder notation. Range is going to be the set of all y values such that, and then what do we know about the y's? So let's think about this for a second. Your inputs, any number that you square goes positive. 4 squared is positive 16. Negative 4 squared is a positive 16. So this x squared right here, the smallest that this will ever get is if you plugged in a 0. 0 squared is 0. So 0 squared minus 3, negative 3 is the smallest output you would get for any number that you plugged in for x. If you look at the graph, that kind of makes sense. You can see that the y values, ones that go up and down, the lowest that this graph gets is a negative 3. All the y values are greater than or equal to the negative 3. So that's how we're going to write that. We're going to say it's the set of all y's such that the y's are greater than or equal to negative 3. Okay, so that's your set builder notation. The other type of notation we use is called interval notation. I'll just apologize right now for sloppy handwriting on an iPad. All right, so we know our domain is all real numbers, so what that looks like in interval notation. We need to know what the boundaries are. What's the smallest number? What's the biggest number in our all real numbers? Well, the smallest number you get goes negative, 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 negative. It's negative infinity. We use a comma. The largest number that we could possibly get is a positive infinity. So interval notation gives us an interval. The number on the left will be the smallest number, the minimum. The number on the right would be the maximum value that you have. And then you have an option. You're going to use either a parenthesis or a bracket, depending on if those values are included. Parentheses means it will never equal that value. So can you ever actually get to negative infinity? You cannot, so we're going to use a bracket. Can you ever actually get to positive infinity? You cannot, so we're going to use a bracket there. So there's interval notation for our domain. We know that domain are all the x's from negative infinity all the way to positive infinity. All right, our range is going to be in interval notation. What's the smallest number? So if your y's are all greater than or equal to -3, well, -3 is the smallest number. And how high does it get? It's every number greater than that. So that's going to go all the way to infinity. Okay, so can we ever touch infinity? No. So we're going to put a parenthesis on that because we don't equal the infinity. But do you see how we did equal greater than or equal to -3? That's where the bracket comes in. We're going to put a bracket on that side with the -3. So our range goes from -3 all the way to infinity, but our range does include that -3. Okay, so we're gonna keep working on that. I know that's a lot of new stuff you guys haven't seen before. So we're gonna work on filling in this chart just to understand how to go between interval notation, putting it in words, and set notation. So our first example is interval notation is 3. That means that it's going to be all the numbers from 3 to 4, and it includes the 3 because of the bracket, and it does include the 4 because of the bracket. So those numbers could be 3, 3.2, 3.78, 3.9, and 4. Just some examples of numbers that are in that interval. So in words, we would say that we're talking about all the real numbers greater than or equal to 3 and less than or equal to 4. By the way, these are all going to be x values that we're working on. These are all going to be domains. Okay, the set notation starts out with a bracket. Oh, my bracket went away. There we go. So it's a set of all x such that, now if it's everything from 3 to 4, so we're going to say 3 is our minimum, less than or equal to, because we include the 3, x, which is less than or equal to 4, and that's our interval notation. Your x is everything between 3 and 4, including the 3 and 4. Okay, next example, all real numbers that are greater than 3 and less than or equal to 4. Since we just did the set notation, let's do that again. So it's the set of all x's such that, so it says greater than 3. So that means their x is greater than 3 if we read it backwards. We're not including the 3. And it's less than or equal to 4. So this time we're including the 4 in our domain, but we're not including the 3. So what that looks like in interval notation, 3 is the smallest number, 4 is the biggest number. We included the 4, so it gets a bracket, but we don't include the 3, so it gets a parenthesis. Okay, next one. All the set of all x's such that 3 is less than or equal to x, which is less than 4. So in words, here's what this is saying. Our domain will be all real numbers that are greater than or equal to 3. There's that greater than or equal to 3, and less than 4, so it does not include the 4. So over here in our interval notation, 3 is our smallest value, 4 is our largest value. X is greater than or equal to 3, so we include the 3, but it has to be less than 4, so we do not include the 4. So bracket on the left with the 3, parenthesis on the right. Okay, so our next one, our interval notation, 3 is the minimum, 4 is the maximum, but we do not equal either one. So in words, that means all real numbers that are greater than 3, because it's not including the 3, and less than 4, because it does not include the 4. All right, so in our set notation, start with a bracket. It's the set of all x's such that, so the x are, we can't include the 3 or the 4, so we're going to say 3 is less than x, it does not include the 3, and less than 4, not including the 4, and we close our bracket. All right, so next we have all real numbers greater than or equal to 3. So if all the real numbers are greater than or equal to 3, that means that 3 is our smallest number, and it's all the numbers greater than that. So it's going to go all the way up to infinity. Now remember, we never include infinity, so that will always get a parenthesis. Because it's greater than or equal to 3, we include the 3, so that gets a bracket. All right, in our set notation, start out with that guy. So it's the set of all x's such that our smallest value is 3 is less than or equal to x. And then we're never going to touch infinity, so we're going to say less than infinity. All right, just a couple more. You guys are hanging in there. All right, so our set notation says all the x's such that negative infinity is less than x, which is less than 3. So that gives us our minimum value of negative infinity, maximum value of 3, and then are we including any of those? We're never going to include negative infinity, so parenthesis, but it's less than or equal to 3. That or equal to has us include that. So then in words, that's going to be all real numbers that are less than or equal to 3. All right, then we got our last one. This one, from negative infinity all the way to positive infinity, that's all of the numbers. So when we have to write it in words, that's just all real numbers. I'll just write it out. So sloppy. And then in our interval notation or our set notation, it's the set of all x's such that from negative infinity is less than x, which is less than positive infinity. All right, that was a lot of information. Oh, we're not even done with this video. All right, we got to keep going. Hold on. Okay, we have an air tanker that flies over forest fires and drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of water the air tanker can drop in x seconds? So what this would look like as a function, f of x is the total volume of water is equal to 400 gallons times x every second. So that's the volume that the air tanker can drop. So domain, let's think about this. Our domain is our input, our x values, number of seconds. Well, we're not going to have any negative seconds, so we know, here's just some side notes, that our seconds will be greater than or equal to 0. And then if we're going to drop 400 gallons every second, at some point you're going to run out of water, and that would be your maximum number of seconds for dropping water. Well, how long will that take? We have 8,000 gallon capacity in the air tanker. If you divide that by 400, because we're going to lose 400 every second, you're going to get 20. So 20 seconds is the longest that this would take. So our x value will be, which is representing time, less than or equal to 20. So our domain in set notation is all the x's such that 0 is less than or equal to x, which is less than or equal to 20. So between 0 and 20 seconds is how long we will drop water. What that looks like in interval notation, 0 is our minimum, 20 is our maximum. We are including both values, so those would get those brackets. All right, so our range is the total volume of water in the air tanker. Well, the most water in the air tanker is 8,000 when it's full, and the least amount that it has is 0 when it's empty. So our range is everything from 0 to 8,000. So in interval or set notation, the range is all your y's such that 0 is less than or equal to y, which is less than or equal to 8,000. In interval notation, 0 is our smallest, 8,000 is our biggest. We do include the 0 and the 8,000, so those would get those brackets. Whew, all right. Nice work.